So one more time, please keep your microphone muted. You can submit all your questions using the chat, or through the presentation you're gonna see my email. You can submit your questions directly to my email as well. I said before, if you have any issue seeing the screen, just do right click on the screen and select the option fit to frame. And one more time, what we're doing today, we're following our cybersecurity discussion. We're complementing what we talked about last time. Previously, we start with why we're talking about cybersecurity. During that discussion, we talk about how and who is behind cybersecurity, and the most relevant, behind the cyber attacks. And we create a series of conditions about how to identify, how we can call these bad people and what they do. And we introduce a very interesting concept. DEF CON is the world's largest, longest, continuously run underground hacking conference in Las Vegas, Nevada. And we introduce them because they are not the problem, they are part of the solution. And so we have a discussion about what they do, how they proceed. And during that session, our conclusion was, well, it's about human errors. And today, we're going to explore a little bit further. Our working agenda today starts with a very simple principle. As industrial systems become more connected, they also become more exposed to vulnerabilities. Easy logic, right? To this, add legacy equipment, safety regulations that may prohibit any modification made over your equipment or the equipment overall. Compliance regulation that requires sensitive data to be made available to third parties. With all this, you're gonna have a very interesting challenge on your hands. We're on the peak of the fourth industrial revolution, where machines talk to each other, we hear that. Robotic process automation is at the forefront of repetitive process. Machine learning, artificial intelligence are opening new venues to how to do things more efficiently, reliable, and cost effective. And we're doing all this, we're doing this webinar and we have this discussion because we need to understand that language of IT and OT convergency. And to do this, we have the support of a very good turtle friend.
Hi, my name is Eric Jenner, Director of Operations for the Networking and Security Division at JMP Solutions.
And with that, let's see the news.
Kansas town is now on the front lines of a cyber war. Hackers targeting the town's nuclear power plant.
41 investigating after a hacker broke into the computer system in a water treatment facility in Florida.
U.S. officials say a massive cyber attack discovered a week ago and blamed on Russia was
concerns this morning on the extent of a cyber attack on U.S. federal agencies. Officials now believe hackers targeted at least a half dozen government agencies.
Wow. Sometimes I feel that we're drowned in information but starved for knowledge. I can tell you this much. Our customer industrial network infrastructure is central to everything they do in the connected enterprise. Our customers need their industrial network infrastructure to be what? Robust, reliable, and secure. However, the knowledge that is required to effectively converge plant floor with IT technologies can make this very difficult. It's important to understand that IT and OT has difference. Industrial environments usually have lower volumes of traffic than IT environments. Much of the traffic is traveling between endpoints, very specific endpoints. Therefore, it could be easily to baseline or inventory these OT devices, easier than IT. But that doesn't mean that it's less work when you think about cybersecurity. As you can see on the screen, there are very clear differences. IT is dynamic, OT is deterministic, IT data is the king, OT process is the king. Understanding this difference is fundamental when you are deploying solutions out there. If this is not clear, the result is massive attacks and disruptions. This attack has a consequence. One of them is disruption in all operations in the factory floor. And we know what is the cause of this, right? Hundreds or millions of dollars in losses. So we're talking about security because the impact on the factory floor is big. Now, last year we started with Ekans ransomware. Last year was a very special year about cybersecurity. Ekans target 64 specific industrial control system mechanisms. One of them was SQL servers. Through the whole year, we saw problem after problem. And by the end of the 2020, in December, we heard about a big programming software, a monitoring tool that is being for many people. They trust in that tool to see what is inside the network. Bad guys use it to get inside the network and create disruption. Now, I know what you're thinking. Most of the hacking is remotely, and it's true. Probably more than 2/3 of hacking attacks are because of remote connectivity. But that doesn't mean that internally we're not going to have any issues. 1/3 of most of the attacks are in-house. Happy mistakes, or happy accidents, you may call them. Well, the statistics cannot be more clear. 95% of cybersecurity breaches are caused by human error. The average cost of that data breach is more than $3 million. Please mute your microphone. Thank you. The average time to identify a breach in 2020, guess what, was more than 200 days. This is following IBM. The average life cycle of a breach from identification to containment was 280 days. Can you imagine having a headache for 280 days? Now you may ask, what about IT devices? There is more than 5,000 attacks per month when you think about IoT devices. Now, who is overseeing all this? The Cybersecurity and Infrastructure Security Agency is the nation risk advisor. We go there to find what's going on. This agency works with partners to defend our infrastructure against today's threats. It's collaborating to create a secure and resilient infrastructure for now and the future. But think about it. When you go there, you are reacting to a problem. It could be already too late. You could be experiencing a problem. So you're going to this side and you're consulting with them to say what I can do, what happened here. So we have to move from what's going on before to what's going to happen in the future. Well, the truth is this one. We have all kind of customers. You deal with all kind of customers. Their network are different. The way that they see the network is different. The impact that they have in our society is different. The way that they compromise with their network and their end product, it could be different between them. There is a cost associated when one of these networks fail. Everybody pay the ultimate price when this network fails. Something interesting is that new technology and old technology are always going to live and work together. We found this type of panels, this type of networks in all around our customers. Old and new technology, they have to work together. And that means what? That we have to make sure that modern equipment can interface with legacy models that they have come to replace or augment. But there is a very interesting twist in the story, if I may call it. IT budget spend most heavily on software and hardware, with a very small percent, 7% of the budget is going to cables, bounding, grounding, connections, endpoints. 80% of network problems are caused by only that 7% uninvested budget. And very interesting is sometimes these problems can be associated with an attack when it's always a problem related with your cable, your connectors, and your endpoint. Many times when we study a network, we found that it's not the configuration, it's just the infrastructure, the physical infrastructure behind the network. Now, the bad guys are taking advantage of this. They know that you're combining new technology and old technology. They know that you are not doing the best and not doing the minimum to keep this network secure. So you may say, well, where they go to find the tools to attack us? Well, we may say, go to the dark web. Do you know what is the dark web? The dark web is a part of the internet that is not indexed by any search engine. Most of the Ethernet information is in the dark web, but we don't have to go there. Forget about going there. Let's stay with what we know. Let's stay with Google. So if I do a Google search looking for tools that I can use to attack a network, I don't have to go too far away. This is a good place to start. GitHub is a for-profit company that offers a cloud-based Git repository hosting services. 87% of developers actually go to GitHub and they place all their code there and they share that code with everyone out there. It's like a fantasy world for open source. I don't have to dig too much in GitHub to find PyLogic. What is PyLogic? It's a Python-based API that I can use to download to a very simple piece of hardware for less than $50 and emulate a CompactLogic or a ControlLogic PLC. So this is quite interesting. I can mimic an actual real device in any Ethernet IP network out there, and I have to invest less than $50 to do it. Now imagine this, if I can make a device inside the network, the only thing that I need to find is the network. I need to find where these open networks are that I can go easily and create disruption. How I'm gonna do that? Well, you may hear about this before from me or from someone else. Shodan. Shodan is the first work engine for interconnected devices. And what you do with them, like Google, you can just place a keyword, a vendor, any vendor that you want. It's gonna narrow down the search to a very specific type of vendor or information, and it's gonna give you a set of products related with that vendor, if I can call it. You can pick one of these products, the one that you think that is most convenient for you, for your attack, and at the end, you're gonna get a result very interesting. That is the logical and physical location of this place. Where is, in which city, and then the IP address that you can use. So when you think about it, I get access to the system already. So the only thing that I have to do is start playing. Playing with what? Well, let me present the hacker tools for 2021. What is this tool? What we can do with these tools? Well, let's talk about some of them. Wireshark is a great and extraordinary tool that we use to identify problems in the network, but it can be used also for bad things. John the Ripper, probably the best known and loved password cracker in the world. Many other teams out there are using these tools to create massive disruption. Before you saw AirCrack, a great tool for wireless networks. And in this list, you can see also Nmap is a network mapping tool. So literally you can have this tool, run it, and it's gonna discover what kind of devices you have in the network out there. Well, let's see all this in action. So let's say for a minute that we want to identify Adam House. Where is Adam House? So to find Adam's house, I need to find the city, the address with street number. Once I get into the house or are in front of the house, I need to identify if I'm gonna get inside the house using the door, the window, the chimney. And inside the house, I have to become an imposter. I have to use a mask so people won't identify me as a stranger inside the house. how these terms and what is the logic behind this when you think about networks? Well, if you want to identify a PLC, an HMI, or a network overall, you can start with the IP address. Where and how to find the IP address. Once you identify where this device is, you're gonna try to get inside the device, the door, the window, or the chimney. We identify that like ports. And then you want to talk with this device. So you want to be an imposter, you want to use a mask, you want to make believe that this mask that you belong to that network. How is possible to do that? Well, as mentioned before, we can take one of these tools and we can get inside. Now, we're not talking about houses here, right? We're talking about what? Factories. So how a factory can protect themselves from all these type of tools and attack and intrusion? Well, one way to do it will be with firewalls. Yeah, makes sense. But there is something very important. Remember, IT and OT are not the same. So we need a very specific type of firewall here. Probably something that we can call an industrial firewall. The discussion about protection involves many things. The discussion about protection means let's use common sense. But sometimes common sense is not enough.
I think when we look at OT network authentication, I think the biggest popularity will be actually deploying usernames and passwords for every user. It's alarming how many plants I go into where I see a standard username and password for a lot of the HMIs or for a lot of the screens or a lot of the applications, because it simply hasn't been a trend in the OT environment to concern themselves with authorization and authentication and monitoring and logging that type of information.
So when you think about the password, where the program running in the PLC, how the PLC interact with the input and output from the point of view of the hardware, you may imagine something called as operative system. Well, inside your PLC, inside your HMI, inside your drive, there is a real-time operational system. And to be more clear, it will be something called VXWorks. VXWorks is a real-time operating system developed as a proprietary software by Wind River Systems. Why this is important? Well, VXWorks is designed for use in embedded systems, your PLC, your HMI, your drives, systems that require real-time, deterministic performance, and in many cases, safety and security certification. All these devices are going to be working in many places like aerospace and defense, medical devices, industrial equipment, robotics, energy transportation, network infrastructure, automobile, you name it. VXWorks is everywhere. So it makes sense that an attack over VXWorks is attack in many devices at the same time. So obviously, if we go into our cybersecurity advisor, we're going to find that, yes, VXWorks has been attacked. Now, since 2001, there is a strong relationship between VXWorks and Rockwell. And we found VXWorks in many things, many controllers, many I/O models, servo drive, you name it. So an attack of VXWorks implies an attack over Rockwell as well. Now you may say, well, if this is true, why the bad guys are not using it? Well, they did. And actually we find a superhero that is warning us about this type of attacks using VXWorks, exploiting the vulnerabilities of VXWorks on Rockwell devices. You want to hear one of these superheroes fighting hackers?
What are the fun facts about Micrologic's 1400 series? You should be buying one today to hack. It's pretty fun device. Right, so first of all, it runs VXWorks. VXWorks is one of the most popular real-time operating systems on the industry. It's on everything, right, including PLCs. And there are a bunch of vulnerabilities reported for that device. Guess what? I bet most of those works with Allen Bradley as well. Right? It is one of the most popular Allen Bradley PLC. You see that everywhere. And it supports Modbus TCP. That's why the injection attack worked. This is my favorite feature. It can be killed remotely by sending a bad Modbus packet. This is great.
Well, perhaps it's not great for the company that not knowing this has been affected by this type of attack. So let's have a clear perspective about what we're going to do after. What is the best way or the best course of action? So the first thing we have to understand is this. A great differentiator in business is when an organization steps out and creates value from something that never tried before. So understanding how these devices talk, what kind of information they have, it's important. But it's also important to see how they connect to each other. What is the path from going from the PLC all the way to an SQL server collecting information, or even beyond? Understanding how these devices is interconnected in your factory floor, at the customer factory floor, a small or big network is important, is essential. And how you do that? Well, we know how. We proceed with an assessment of your physical network, an assessment of your logical network. It's critical to understand that assessment. It will provide an inventory of services and devices. It will show me what I have to do about patches. It will show me a list of vulnerabilities and risks in my network. And eventually, it's going to give me an indication about I need to secure this specific area of my network more than any other one. When I have a clear view of what I have in my hands, what is in my network, then I can think in something even better. Integrating all this will land in a concept that is called defense in depth. What is this? Well, pretty much refers to an information security approach in which a series of security mechanisms and controls are thoughtfully layered through the IT/OT network to protect confidentiality, integrity, and availability of the network and the data with it. All this sounds great, right? But what is the right solution?
So right solution and right vendor really depend on the customer and their current landscape. So at JMP Solutions, we always start with an assessment and a detailed discovery and road mapping session that covers the networks, the industrial data center infrastructure, as well as getting in depth on the PLCs that are in use and the control systems in use. You can't really just go out, grab a vendor based on their rating and say, come and do this job. I think we really have to dig in and understand the technology that's in use now, standard architectures that are in use now, whether they're designed in-house or pushed down from corporate, and then come up with a right solution that fits that customer and their security standards. I always say to my customers when we're talking about this is there's a lot of investment already in staffing and hardware and software and technologies in the enterprise layer for security. So let's take advantage of those and build an architecture and build a solution that interacts and works with those solutions so that we can take advantage of the investments already made at the IT layer and kind of bring them down into the OT layer. And I think that's really what Cisco, Rockwell, and the CPwE are focused on is making it a top to bottom solution and architecture that's manageable and securable very easily.
The Converged Plan Ethernet is a collection of tested and validated architectures that are developed by subject matter authorities at Cisco and Rockwell Automation. The CPwE Industrial Security Framework, using defense in depth approach, is aligned to industrial security standards like the IEC 62443. All the information that you need and that you want about the CPwE and security is one click away. Rockwell offers this information in different formats, and actually it goes one step forward because it allows you to practice in virtual labs many things about cybersecurity and many of the concepts that we're covering in this webinar. So I will invite you to reach us and many other people here in Toronto Hughes about these tools, these virtual labs, and beyond if you want to know more about cybersecurity. Now, during the discussion, we said, how I'm going to make an assessment? I know that I have a network, but I don't know how to scan this network. What is the way to reach out and find what I have in my network? Well, that's what we're talking about, visibility and identification. So there is a great tool for that. It's called FactoryTalk Network Manager. Scanning the network, it will give you a first approach of how devices are connected, from where to where there are connections or endpoints, what kind of devices you have. Seeing these devices, how they're connecting, how they interact with other devices is great. It will help you about this idea of your assessment. Once you know what is there, how it's connected, then you have a first idea of what to do next. Let's say that you just want to keep these PLCs in place. You don't want to modify or update the PLCs. The only thing that you want to do is to protect them, protect link to these PLCs. Well, one option could be just adding proxies. The idea of a proxy is that it's going to help you establishing a secure connection to an existing PLC. Another option is probably adding industrial switches or updating from unmanaged to managed switches. An industrial switch is very special. One of the first things that you have to realize is that it has the possibility to interact with your PLC program. Also, has to be able to be open for IT. You want IT to be part of this equation. You don't want to fight against them. You can present a tool that they can use. Stratix has a great set of different type of switches, and one of the latest one is the Stratix 5800. With these switches, you can do something that is fundamental when you think about security in your network, and it's segmentation. There are many flat networks out there, every single one running over the same VLAN, VLAN 1. Flat networks and VLAN 1 is a recipe for problems, and one bad guy can use this against your network anytime, once get access to your network. Now, before we have a very interesting discussion about firewalls, let's go deep one more step about firewalls. The firewall is going to protect me. It's going to protect my network against intrusion. We are defining industrial firewalls. One example of an industrial firewall could be the Stratix 5950. Now, what exactly does a firewall? Well, initially, it's going to protect your network from MAC addresses, IP addresses, source and destination that are out of place, or that doesn't belong to your network. You're going to also block different type of ports and protocols, and that seems to be fine. An IT person will say that's enough. Well, for us, it's not enough. We need something else. Remember that I said that I can reach the house, get inside the house, and use a mask to impersonate something else? I can impersonate a virtual device that is doing bad things in the network. So I need to understand what that device is doing at the protocol level, how this device is having conversation with other devices. And to do that, the industrial firewall has to do something called deep packet inspection. And because we're talking about Ethernet IP and Rockwell, there are something very special about deep packet inspection. This firewall that you have to use, it needs to have something inside called the CIP preprocessor. It's a piece of software that is going to analyze the data that you're exchanging between devices. And this is important because there are many devices out there that use Ethernet IP. So a firewall initially can see what these devices are doing. But remember, there is something extra about Rockwell. So let me show you this. A generic CIP device seen for an industrial firewall pretty much has this function: read, write, some administrator rights for the very specific things to do over the device. Look at this table, and now compare this table with Rockwell, the CIP version of Rockwell. Immediately you will see that there is a big difference here. And that's why when we talk about firewalls with some of our customers, we advise them to follow up the list of ports that need to be added to the firewall for many services in FactoryTalk that need to be run properly. So as you can see here, there is a big differentiator between a standard industrial firewall using CIP generic and one that has and understands the extended version that Rockwell uses. Why is this relevant? Well, it's relevant because remote access. You can see here all the steps that a remote access connection is supposed to do before reaching the final destination, a PLC. This is CPwE in all its glory. But what is interesting about is sometimes our customers, they take a short path. They said, I'm going to avoid going through IT, I'm going to avoid going through the network, and now after this, yes, I'm going to do it because this is very complicated. But that external path, it has consequences. And the consequences could be thousands or millions of dollars. And in many cases, as we saw recently in Florida, human lives. So sometimes maybe it's not worth it to take that risk. Well, there is something else. There is anything else that we can add to this discussion? Yes, there is. Big data analytics analyze large amount of data to uncover hidden patterns, correlations, and other insights. With today's technology, it's possible to analyze data and get answers from it almost immediately. And where is all this data will be? Up there, in the cloud. This effort is extremely slow and very inefficient with a traditional business model, the traditional connection between devices. So we need to take advantage of this way to see data. But when you talk about edge, fog, or cloud, now you're going to expose your devices to billions of devices, connecting to millions of nodes, reaching out thousands of servers out there. So this is a new layer of complexity, and we have to be ready to address the concerns that our customers will have about it. Today, customers are talking about bringing the information to the cloud. Why? Well, success is not about the quantity of data. No way. It's about the quality of data. How consistent is the context of this data, and if the data is ready to be used. Introducing different technologies from Rockwell would allow us to answer the question about this paradigm about data. Hundreds or perhaps thousands of data points are collected for any process today. All that information needs to be formatted in a way that it could be easily accessible for many other type of applications. Why we're doing all this? Because we need the data on premises, on the go, from the cloud. This data need to be easy to access because we're going to use it for many tasks. This data will allow me to have and make informed and smarter decisions in many types of markets: manufacturing, oil and gas, automotive, food and beverage. All this data is important and relevant, and all this data is supposed to be the right data with the right context. We have to secure this data. Collecting this information and sending this information all the way up to the cloud requires attention and patience, of course. Success. You want to be happy faces. You want to see how this data is helping organizations and your business to be more productive, to reduce complexity. Well, we need to monitor. We need to introduce techniques that would allow us to have a secure channel, encryption, and many other new things behind the concept of data protection. There is one more factor to talk about here. What about 5G? Sending information to the cloud is not going to be pretty much done by cables, right? What about the factory floor? Can I have all these goodies about wireless connectivity in the factory floor? Can I take advantage to it? Yes, we can. 5G networks will supercharge the convergence between IT and OT. There are many benefits. Industrial machines, sensors, and other connected devices can learn on the fly using artificial intelligence and machine learning. We talk about resiliency and redundancy in our networks. We hear our customers talking about that, asking us for that. Imagine a new way to address that requirement of redundancy and resiliency. where no matter what, the information always is gonna reach the end device. Additionally to the merge of IT and OT, both teams can much better share information and use the big data to improve the process, workflows, and overall make machines more efficient. What you can see on the screen right now is an actual model of one of the most difficult tasks in the factory floor, the pick and place. Identify wrong pieces, segregate these pieces, and put it aside. Now imagine this, a machine like this one that can be any place in the factory floor. So the factory floor is not gonna be anymore a fixed arena. The wire factory today makes us place devices in the same place no matter what. The wireless factory, the future implies devices talking to each other, exchanging information. You can modify your factory floor based on the demand that you may have about specific products. Well, overall, automation strategies are evolving in the face of the competitive global economy. We see it now with the after COVID recovery. The systems that control our industrial infrastructure are becoming increasingly integrated and interconnected, requiring an increasingly level of attention, a greater degree of standardization in all levels of the control architecture through the IT layer. Legacy programming environments of widely used industrial machines could harbor virtually undetectable vulnerabilities and malware. We saw it before about Modbus TCP. These issues are difficult to resolve because they are inherent to the design of the machine, and legacy programming environment, guess what, cannot be easily replaced. That's why, my friends, building a strategic relationship with key vendors is a crucial part of a cybersecurity solution. It will deliver competitive advantage. This collaboration can help our customer, your customers, to harness the knowledge and flexibility needed to respond to rapid change in or on shifting demand. I have to say that I really appreciate your time today. Thank you for being a total partner. Please submit your questions through the chat. You can reach me if you have any interest to see and talk with Eric. Please, his email address is on hand. Looking forward to hear your questions, looking forward to hear your project, and let's together beat the bad guys when we talk about cybersecurity. Thank you.